We've walked on the moon and connected continents with underwater tunnels. Yet, when modern engineers look at the Great Pyramid of Giza, they start to sweat. Look at the sheer physical reality of this structure. It stands 147 meters high, sprawls across 12 acres of desert, and weighs a staggering 6 million tons. People often assume that with our advanced technology, we could throw one of these up in no time. But the truth is much more intimidating. So let's test that. We are going to draft a phase-by-phase blueprint to construct a one-to-one full-scale replica of the Great Pyramid in the year 2026. The ancient Egyptians had immense religious devotion to fuel their decades of labor. Without that drive, building a pyramid today becomes a brutal, unforgiving equation of pure economics and logistics. The very first bottleneck we hit is the ground itself. You cannot drop 6 million tons of rock onto normal desert sand. It will simply sink. The ancient engineers learned this the hard way. When building the bent pyramid for Pharaoh Sneferu, poor bedrock support caused the massive structure to start leaning, forcing them to suddenly change the angle of the walls to avoid total collapse. Comparing foundation weights, the massive Burj Khalifa is only 8% of the Great Pyramid's staggering demand. To prevent sinking, we must pour a 4-meter-thick reinforced concrete mat, requiring 500,000 tons of material. Before a single stone block is placed on the site, leveling the ground and pouring that foundation hits us with a staggering cost of $550 million. Next, we need the materials. Our blueprint calls for 2.3 million individual stone blocks. If a standard modern quarry produced 100 large blocks a day, it would take 63 years just to fulfill the order. You can still see the overwhelming volume of material the ancient Egyptians had to carve out of the Aswan bedrock by hand. To finish this job in a modern 5-year timeline, we'd need to run 250 industrial diamond wire saws simultaneously directly inside the quarries. But these machines are massive power sinks. Running that many saws at once pulls 20 megawatts of power per hour. Over 5 years, that operation alone would consume roughly the equivalent of the daily electricity usage of the entire country of Italy. This rolling receipt tallies up our new expenses. When we add the cost of the raw limestone, the 80-ton granite slabs for the King's Chamber, the heavy machinery, and that astronomical power bill, our budget spikes past $1.95 billion. The true economic weight of these materials lies in the massive energy infrastructure required to slice millions of stones at a modern industrial pace. Now we have to move 6 million tons of cut stone across the 900-kilometer stretch from the Aswan quarries up to Giza. To keep our 5-year timeline intact, we would need 500 heavy-duty flatbed trucks on the road, running a continuous, endless loop every single day. Once the blocks arrive, we hit the final, terrifying bottleneck: gravity. Standard construction cranes simply cannot lift an 80-ton block of solid granite 147 meters into the air. The physics don't allow it. We have to deploy a complex network of specialized Kroll K10,000 tower cranes, some of the largest in the world. And as the pyramid grows taller, these massive machines have to be constantly disassembled and re-anchored higher up the slope. Add in salaries and insurance for an army of 3,000 workers, plus the brilliant white Tura limestone required for the perfectly smooth outer casing. This final on-screen tally shows our complete logistics and labor expenses. Factoring in this specialized transport, custom crane network, workforce, and finishing materials, physically assembling this structure pushes the absolute weight limits of standard construction equipment, bringing our baseline total to nearly $3 billion. $3 billion is a massive figure, but it's not unheard of today. The high-tech SoFi Stadium in Los Angeles and the artificial islands of the Palm Jumeirah were built for roughly the exact same price. The difference is pure economics. Those modern mega-projects generate massive continuous revenue and utility. Our replica pyramid is essentially a $3 billion solid rock tomb with zero economic output. We possess GPS-guided bulldozers, diamond wire saws, and reinforced concrete. Yet organizing the capital, materials, and supply chains to build this shape still tests the absolute limits of the modern industrial world. Now strip all of those modern advantages away. No engines, no electricity, no hydraulic cranes. Our modern blueprint serves as a testament to the ancient Egyptians, who mastered a logistical and organizational art that still challenges the limits of our engineering.